pass across. But with your assignments, that's the feedback from you. Will help you understand the areas wherein you are lacking behind, and then I can actually work on it and it will help you. But today we're looking entirely into a new topic which is on the board: scalar and vectors. Scalar and vector. This topic should not be difficult for you to comprehend, in the sense that we had intro into it when we did motion. That was in first or in the second term when we had motion in physics. We differentiate physical quantities, we're able to classify them into vectors and scalar quantities. Now, I just have to put this on the board so that it will help you follow me in the direction at which I'm going to drive now. Okay, first of all, we'll be looking at, in this topic, we'll be looking at concept of scalar and vectors. Concept, a little bit what it entails. Concept of scalar and vectors. And when we are done with that, we'll look into vector representation and composition. How can you represent a vector and how can you compose a vector? And then when we are through, we will go into the next subheading, which is the next subtopic objective, the resultant of two vectors. How can you result two or more vectors? How can you result two or more vectors? Is that clear? And then by now, you should be running through your mind the definition of a scalar quantity, or what scalar entails and what vector quantity also entails. I said scalar quantities are those which are only magnitude or no numerical values. They are only magnitude or no numerical values, but no direction. In other words, scalar quantities are quantities that have magnitude only without direction. That's what it means. They have magnitude only, but they are without direction. Examples of those quantities is already stated clearly on the board. You have length, you can call it distance. If you don't call it length, you call it distance. Mass is another. Volume, density, time, speed, temperature, and energy. All of these are classified as scalar quantities. All of these are classified as scalar quantities. What then is a vector quantity? I think your answer should not be far from what I've explained so far. If a scalar quantity consists of magnitude only without direction, then a vector quantity should contain both magnitude and direction. So I would say that vector quantities are those which have both magnitude, we call it size. If you don't call it magnitude, you call it size, and direction. So vector quantities are those quantities that have magnitude and direction. Quantities that have magnitude and direction. Now you don't just see the value of it, but you see the direction at which, if it's a force, where the force is going. If it's due north, if it's due south, if it's due west or east, and so on and so forth. Examples of vector quantities is also on the board. I said they are displacement. Mind you, you can differentiate between displacement from distance. Displacement is the distance traveled in a specified direction. That's displacement. Distance traveled in a specified direction. Another example of vector quantity is velocity. You have acceleration, you have weight. Of course, the weight of a material, particularly when thrown up, acts downward. That is the gravitational pull of that object. When it's acting downward, you can actually measure or determine its direction. So that is why it's a vector quantity. Force is a vector quantity, and then momentum is also a vector quantity. I think this is simple for you to assimilate. Definition of vectors and scalar, examples of vectors and scalar. All of these constitute the concept of vectors and scalar quantities. I'll attempt to differentiate between scalar and vector. I will attempt to differentiate between scalar and vector. If we say a scalar quantities have magnitude or numerical values only, then you can put it there. Scalar quantities have magnitude only. Whereas vector quantities have both magnitude and direction. Is that clear? Now the first difference between scalar and vector. You can take it as number one. Number two. Now, scalar quantities are added numerically, that is, using arithmetic. You can say scalar quantity are added using the arithmetic process. Using arithmetic, whereas vector quantities are, you don't say added, you can say they are resolved. Just like we said are added here. You can say either they are added or they are resolved. Vector quantities are resolved using geometric analysis. You say that? Okay. So I think it is clear now the differences between scalar and vector. Whereas scalar quantities have only magnitude, vector quantity has both magnitude and direction. Whereas scalar quantities are resolved using arithmetic process, vector quantities are resolved using geometric analysis. Is that clear? Okay, now we are on to representing vectors. How do you represent vectors is what we're going to look at now. Now, in representing vectors, first of all, what gave us rise to representing vectors is because they don't just have magnitude. They have both magnitude and direction. When you see the numerical value, you can also see the direction to which that value is. Okay? I said, since the vector quantity has both magnitude and direction, we represent such a vector by a straight line which has an arrowhead indicating the direction of the given vector. The length of the line is drawn proportional to the magnitude of the vector. In other words, what this simply means is, now if the length is, let's say, 3 meters due east, now you don't measure what is either below 3 centimeters or above 3 centimeters. You measure the exact length of it to represent the length that is stated in the question. Just like we have an example on the board, which is represent a displacement of 300 kilometers to the east. Represent a displacement of 300 kilometers to the east below by the straight line AB, 3 cm long, which points towards the east from a chosen origin. Now, if you look at this exercise already, have given us a scale that we can adopt. If we are taking 300 kilometers to the east, it therefore means that our scale will be 3 centimeters. In other words, the 1 centimeter will represent 100 kilometers. If 1 centimeter represents 100 kilometers, therefore means that 3 centimeters will represent 300 kilometers. That's the first thing you must know. And without that, you're going to draw it anyhow, which will not be correct. Okay. Okay. I don't know if you have ever seen a compass before. How is a compass drawn? Okay, this is north, this is south, this is east, and this is west. So before you can represent a vector, you must have the knowledge of compass. This is in the lab. Maybe Wednesday I can show it to you. It's a compass. Now, if you are asked to represent, just like this exercise, we are asked to represent it to the east from a chosen origin. Let's assume this is my origin. Right? From this point upward is due north. And then from this point eastward is due east. Isn't it? Now I can simply measure 3 centimeters due east because we are representing it to the east. Isn't it? We are representing it to the east. So from this point to this point without including this other side, I can represent the vector. And what I said is with straight line AB. So this is A and this is B. This is A, this is B, and then this is what? 3 centimeters. Don't forget we have a scale. We have a scale which represents 1 centimeter is to 100 kilometers. So where the displacement is 300 kilometers, it is represented as 3 centimeters. Is that clear? Did you get that? Can we do the second one? Okay. So we have represented that vector due east. We have represented this vector, due east. Now we're going to represent the second vector. Or the second question says represent a velocity of 50 kilometers per hour. 50 kilometers per hour in a direction not 60 degrees east or 60 degrees east of north, using a scale of 1 centimeter to 10 kilometers per hour. How do you represent that? How do you represent that? First of all, you have to draw a compass that shows the North Pole, the South Pole, the West and the East Pole. Once you are able to locate those points, then it becomes very easy to represent the direction and the magnitude of the vector. Just like this first one, the magnitude is 3 centimeters and the direction is what? East, due east. So the second exercise, we are to represent it not 60 degrees. Not 60 degrees. So what do we do? First of all, this is question 2 now. Let's assume this is my point of origin. And this is north. We present that as N. Okay? And they said not 60 degrees or 60 degrees east of north. East of north. Of course, we have, let's say this is a quadrant. I have removed the south and the west. So I have a bracket with the north and the east. If we are to draw a vector of this sort, now the vector is 60 degrees east of north. Now this angle that is created here is not 60 degrees. This is 90 degrees. You see it? That's 90 degrees. If we are to represent it, 60 degrees will be somewhere here, due north. Okay? So if this angle if that angle is 60 degrees, do not. Okay. Let me extend it a little. Okay. Now, if you look at the question, the magnitude is 50 kilometers per hour. And we have been given a scale of 1 centimeter to represent 10 kilometers. So what length should I have here? If you have your ruler, you can draw it. This should be 5 centimeters. If we are going with a scale of 1 centimeter is to 10 kilometers per hour. Did you get that? Look at it very well. The length, which is the magnitude of the vector, is 5 centimeters. For the fact that we have a scale of 1 centimeter to 10 kilometers. But in the question, it was 50 kilometers per hour. Please take notes. Take notes. Okay? Then it is east of north. This is north. This is east. So east of north. Sustain an angle of 60 degrees. Now, not from the east, but from the north. Do you get it? That is another way of representing a vector. So from these two, I think you can represent as many vectors as you can. Is that clear? Okay, now representing vectors is not just the only thing you are supposed to know. Now, after representing vectors, what does it mean when you add the vector? How do you add the vectors? Is what we're going to look at briefly now in this segment. As an addition of vectors, to add a speed of 10 kilometers per hour to a speed of 30 kilometers per hour, we merely sum up the two magnitudes to obtain a speed of 40 kilometers per hour. This is because speed is scalar. Don't forget where we differentiate between vectors, quantities, and scalar quantities. We said for scalar quantities, we resolve them how? Using arithmetic. But for vectors, we do what? We represent them using geometric analysis. Now, an exercise is on the board for us to resolve. You have 30 kilometers and then 10 kilometers of the speed. Now, if we have a straight line from, let's say, point A. Now, the man walked, yes, we measure the first 10 kilometers. Measure the first 10 kilometers, and then he proceeded to another 30 kilometers to point B. So, in adding this vector, we only sum up the first movement the man made from point A to this point, and then to point B. That means 10 plus 30. 10 plus 30, of course, you know, is 40. So we have 40 kilometers per hour. We have 40 kilometers per hour. So this is simply added. By adding 10 to 30 gives you 40 kilometers per hour. But that's simple enough compared to this other example or illustration. Suppose two forces, P and Q, of 5 Newton and 4 Newton respectively, act on a body in the same direction. The resultant force or net effect of the two forces is given by R is equals to P plus Q. It's as simple as that. R is equals to P plus Q. Let's take that solution. Okay. Now we said you only sum up the two magnitude to obtain the total magnitude of the force in this case. Now, if we have two forces, P and Q, The summation or the resultant force R is equals to P plus Q. Whereas P is given to be 5 Newton and Q is given to be what? 4 Newton. At the end of the day, R is equals to 5 plus 4, which is what? 9 newtons. 9 newtons. Is it not simple enough? And gradually we are moving deeper into it. Now for the first one, it was very simple. You had to sum it up. The second one, the same thing. But look at the third one. This is supposed to be number 3. How do you resolve this? How do you resolve this? A man starts from A and walks 3 kilometers eastwards and then 4 kilometers southwards. His motion can be represented graphically below. How do you represent this motion? How do you represent the motion? Do I give you a time to sketch it out? Well, I don't think so. Let's do it together. Let's do it together. Let's use this side of the board. We will not just resolve it, we'll find the resultant force. Alright. Now the first thing you do, you imagine it from your head by interpreting the question. That's what physics entails. You just jump into a question and start. No, you first of all analyze it. Let's analyze this question again. We are not just representing it, we are going to get to a particular point. Watch out. A man starts from A. Okay, let's assume this is point A. That's point A. Follow me carefully. A man starts from point A and walks 3 kilometers eastward. Of course, you know your east is this side, right? You have your east this way. How many kilometers? 3. Let's assume this is 3 kilometers. Okay? Now 3 kilometers. Eastward. It has moved eastward. And then 4 kilometers southwards. Isn't it? 4 kilometers southward. In other words, the length from this point to this point will be smaller compared to the length from this point, which is 4 kilometers. So we have, if it's coming down, which is southward. You see, this is 3 kilometers. I take this, I'm estimating anyway, it can be 4 kilometers. Right? 4 kilometers. Let's take, this is point A and this is point B. Okay? His motion can be represented graphically. Now we have tried. Okay, from this point, if you join this point to this point, sorry, let's say this is point C. It sustains an angle alpha that way. Isn't it? This becomes the resultant R of A to B, B to C. Now it's possible to resolve or to find the resultant vector here. Of course, maybe you've been taught in mathematics, Pythagoras Theorem. If you've not been taught, you better go back home and learn, or stay at home and learn it. Pythagoras Theorem, we call it Scalar. Here you have the opposite, the adjacent, the hypotenuse, and so on and so forth. Now, if there's an angle here, automatically this becomes what? The adjacent, right? To this angle. Whereas this is what? Opposite. I take that again. If it sustains an angle alpha this way, ABC becomes opposite, whereas AB is what? The adjacent. So if we have adjacent and opposite. What's that? From Scalar to R, you have AB, BC. You have an angle. So adjacent over hypotenuse, you have the sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tan is opposite over adjacent. So which one are we going to apply? Which one do we apply? We have adjacent, we have opposite. Right? In other words, it's going to be tan. But before that, you have AC squared is equals to AB squared plus BC squared. That's Pythagoras Theorem. We are into mathematics now. In other words, we are looking for arrow. Arrow represents AC. That's why AC is equals to AB squared plus BC squared. So AB is 3 squared plus BC is 4 squared. So we have AC squared equals 9 plus 16. Because the square root of 3, the square of 3 is 9, and the square of 4 is what? 16. I think I should use this side of the board to finish it off. Now, AC squared is equals to 9 plus 16 is what? 9 plus 16 is 25. Okay? So, now what do you do? If you square both sides, what happens? You have AC equals the square root of 25, which is equals to 5 kilometers. Did you get that? So R, which is the resultant of those two vectors, AB and BC, is equals to 5 kilometers. That's the magnitude. But the direction is simply 4 over 5. Okay? The direction, we have tan alpha equals 4 over 3. Okay, now we have gotten the resultant vector r to be 5 kilometers. Now we needed to find the direction. I say using Scalar, you have what? Opposite over adjacent. Gave us this. Now, if you have 4 divided by 3, you have 1.333 and so on and so forth. Now the reciprocal of tan gives you the angle. Is that clear? Reciprocal of tan gives you the angle of 3.13. That ends it there. Assignment. Find the resultant of two vectors of 3 units and 4 units. And acting at a point O at an angle of 45 degrees with each other. Now please do the assignment and send it. And from there I will know where to dwell on in our next class. Do have a nice time. Bye-bye.